Okay, we're going to be looking at ellipses. There are going to be two kinds of ellipses we're going to look at. When you graph an ellipse, it looks sort of like an oval. So the first kind of ellipse, let me just give an example. Maybe it'll look like this. Oh, my drawing's not too good. This is what I call sort of like I'll call this like a left-right ellipsis, because it's like the long side is like the x-axis. It stretches out to the left and the right. The other kind of ellipse we can have is what I'll call okay, that ellipsis looks a little better. This I like to call sort of an up-down ellipsis. Now let me give you some definitions from looking at these pictures. First of all, we have what's called the center of the ellipse. Pretty much split the difference, both top and bottom, side to side. And that point is normally called HK. It's pretty common, just like the center of a circle and some other geometry stuff. Over here, of course, now the next thing that becomes important is we have these things called axes, and the axes go from one end of the ellipse to the other, and it goes through the center. Now the long one, the longest distance, so in other words here, horizontally, this would be called the major axis. So the longest axis is called the major axis, and in this case, the up and down would be called the minor axis. So I'm not going to do it over here, but the same principle applies. I guess I can draw, like here is like the major axis. In this case, the major axis is up and down, and the minor axis is side to side. But if I look at the distances, you're going to see in a minute when I write out the standard equation of an ellipse, you're going to see H and K, but you're also going to see these letters A and B. And the distance from the center of the ellipse to one edge on the major axis is called A. So obviously this one is also A. And then the minor axis, the distance from the center to the top is B, and to the bottom is B. If I go over here, now sometimes you'll see in some diagrams, instead of doing it A, B, B, they'll just take the whole major axis and they say that distance is 2A, and then they'll take the minor axis and they'll say that distance is 2B. We're really saying the same thing. And then there's one more point that they will sometimes ask you to determine of an ellipse, and you really don't need these 2 points to sketch or graph the ellipse, but sometimes they will ask it. And that's, let me do it over here. An ellipse will have 2 focus points, or the plural is foci, so they'll say find the foci of the ellipse. And what it is, the foci, they sit on the major axis, and they're the same distance on either side. So that's a foci, or focus point. That's a foci. And the distance from the center to the foci is called C. So that's once again number we can calculate. And actually there's some rule where the foci, if you take, I think the way an ellipse works is if you take your two foci, so here's the center, and you take the two foci, it's almost like you take this point, and as this point moves around the circle, these two, the sum of these two distances are the same. So as you move over here, all of a sudden you get here and here, but these two, when you add up those lengths, they stay the same. All right, so now based upon the description, the picture of two ellipses, the left, right, the up and down, let's look at the actual equations. So for a left to right ellipse, the standard equation is going to look like this. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now for the up and down, you notice only one thing is going to change, and that is that the a and b are going to be sort of switched. So let me write this, then I'll explain to you what's going on. Notice in this first one, for the left and right ellipse, the a squared is underneath the parenthesis with the x, and the b squared is sort of grouped up with the y. When I get over here, instead now the x parenthesis is with the b and the y is with the a. Now notice the a has to do with the major axis, and a or let me put it this way. When you look at your equation, to figure out which is your major minor axis, a squared is always bigger than b squared. So what that means is, we'll do some examples in a minute. When you have the equation in the standard form, you simply go and figure out which denominator is larger. And whichever denominator is larger will determine if you have a left or right or an up or down. So for example, just to make an example up, say I was given this equation of an ellipse. This is in the standard form. And I want to know if this is an up or down or a left or right. All I do is I go see which denominator is larger. And because the larger denominator is with the y, then I know this is going to be an up or down parabola. Now let's just take a minute and talk about these standard equations, because what you need to realize is, first of all, notice on one side of the equation you have the number 1. It has to be the number 1. It can't be a 5, it can't be a 25, it can't be a -4. It has to be 1, and only 1 on one side of the equation. And then when you look at the other side, notice you will have two numbers in the denominator. But if you look in front of the parentheses, we don't want to have any coefficients in front of the parentheses. So my example down here, I've got two numbers down here, which represent a squared, b squared. I've got my h and k's inside the parentheses. Here's my x and y. But you notice over here, the number 1 And you notice there's no coefficients in front of these parentheses. Now we'll do some examples in a few minutes where we actually have an equation that's not in standard form, and we're going to talk about the first step to figure out the ellipse is to first put the equation in standard form. So the key things about the equations in standard form, whether you have a left or right or up and down, one side has to be the number 1. You're going to have no coefficients in front of your x and y parentheses, but you will, of course, have numbers down here in the denominator of these fractions. So let's do this. What I want to do is to give you the steps to go through. If you're given an equation, and you'll be told this is an equation of an ellipse, and typically they'll say find the center of the ellipse, find the points for the major and minor axis, sketch it, and they'll ask you for the foci. So basically they're wanting you to find all the information about the ellipse and then to sketch it. So what I want to do is to sort of give you the steps that you would go through to solve those kinds of problems. So let me actually give you a fairly straightforward example of the equation of an ellipse. And based upon that, then we'll talk about the steps you go through to figure out all the important things. So here's the problem we're going to do as we go along. X minus 3 quantity squared over 16 then y plus 4 quantity squared over 9 equals 1. So for this problem, we're asked to find various things. Just so you know, we're asked to find the center. And actually, I didn't say this, but if I go back to my picture, they actually call these points here vertices. Like these would be the major vertices, these 2 points. These points up here would be the minor vertices. So I forgot to mention that. So a lot of times they will say, for this ellipse, find the center, find the vertices, find the foci, and then they'll say, then sketch the ellipse. All right, so those are the typical kinds of things that they're going to ask you to do. Let me over here try and list the steps that you follow to do this kind of problem. And as we give you the steps, we'll step through this problem and then we'll do a couple of others. First thing is, I'll phrase it, get equation in standard form. All right, so you're given an equation. The first thing you have to do is you have to realize what the standard form of the ellipse is, and there's 2 possibilities. There's a left or right or an up or down. These are the standard equations. Once again, I'll say it again. The key is the one side equals 1. You got numbers in the denominator of the fraction, no coefficients in front of the parentheses. So we look at ours, and as it turns out, this equation is in standard form. So for this problem, there's really nothing to do for problem 1. Later on, we'll do some examples where we do have to do some work to get the equation in standard form. For this first one, sort of an introductory problem, an easier one, we don't have to do anything to get it in standard form. The second thing I suggest you do determine what kind of ellipse you have, an up or down, an up, down, or left, right. And the way you do that is you go look, once you're in standard form, you go see which denominator is larger, and the larger number, whatever it's coupled with, determines whether it's left or right or up or down. In this case, 16 is larger than 9, and it's over here with the x. So if the x has the larger number in the denominator, then we know it's going to be a left or right parabola. So I draw a quick sketch. When I get ready to draw my ellipse, I'm sorry I said a parabola, I meant ellipse. If I get ready to draw my ellipse, it's going to look like this. All right, second step, not too hard. Third step, once you're in the standard form, find the center, which is HK. Now, just like in the past with circles and even parabolas, if I go back to standard equations, it's very important you notice. It's x minus h, y minus k for both ellipse equations. That means when you go try and find the center, the easiest thing is that little rule about whatever is in your equation, the center is what we like to think is the opposite. What do we mean by that? When I go look at the x, so this is going to be my h. I like to think of that whole thing as a minus 3. So when I actually define the center, my h is the opposite sign. So up here it's a minus 3. So my center becomes 3 here. For the k, it's like plus 4, which means when I actually define my center, it's the opposite. So this is just a way that students, a lot of times, method they use to make sure they get the right numbers for the center. You sort of use the opposite of what you see in the standard equation. And actually what I might do is, now as I start to determine this stuff, I might actually start working on my sketch. So let me do that here. So the center of my ellipse is going to be 3, negative 4. So 3 in the x direction, then negative 4. So that's going to be the center of my ellipse. Now, fourth step, I'm going to find those variables a and b, which is another way of saying I'm going to find the vertices. Because if we look here at my original sketch, I have a left-right ellipse. A is going to be the distance from the center to the edge of the ellipse. So if I can find those, then I know these points with my vertices. So if I find B, I know how far to go up and down. And actually, once I find A and B, I can pretty much make the sketch of my ellipse, actually. A and B are pretty easy because if you look at the standard equation, in this case, left and right, here's my standard equation. A squared is the denominator of my x term. So it looks like here, a squared is 16, b squared is 9, which means A must be 4 and B must be 3. And now all I do is I basically go for my center. Remember now, A is my major axis, which is horizontal. I'm going to move 4 from the center, move 4 to the left and 4 to the right, because that's what A is. So if I move 4 to the left, that's going to be one of my vertices. And move 4 to the right, that's another vertice. And then B is how far I go up and down. You need to go 3 up, which is right here. And 1, 2, 3 down. 1, 2, 3, 1, 2, 3. And I can just try and sometimes it's hard to draw a nice perfect ellipse by hand. So I'm able to pretty much at this point draw my ellipse. And I can even say the major vertices are here and here. So if the center, I guess I could put this, I already have the center up here. So the major vertices, I moved 4 this way. It put me at -1, -4, and -7, -4. And then the minor vertices, those are the up and down ones. This first one is going to be 3, -1, and then I'm here at -4, so it's 3, -7. And now the only thing left is those foci, which are going to be on the major axis in between the vertices. Now for an ellipse, I don't think I've given you this. There's an equation. C squared equals A squared minus B squared. That's the equation. Because this C is going to determine what your foci are. So for us, A squared is 16, B squared is 9. So C is square root of 7, which if I get my calculator and determine what is that as a decimal, 2.6. That means I go back, if I want to draw my foci on my graph, I go from the center and along the major axis I move 2.6 to the right and then 2.6 to the left. So I'm sitting here at 3. I need to go like to 5.6. So here's 4, 5, 5.6 maybe right there. So there's a foci. And then I move 2.6 to the left. 1, 2.6 maybe right about there. And the actual points would be, so this one is going to be 3 plus 2.6, 5.6, -4. And here, 3, I went 2.6, so it's going to be like 0.4, -4. All right. So that answers all the things they were asking for: the center, the vertices, the foci, and sketch the ellipse. Hopefully not too hard. Let's do a couple more examples with a few little twists. So here's a second ellipse we're going to look at. 9x squared plus 4y squared minus 36 equals 0. So we're told this equation is an ellipse, and we're asked to find the usual center, vertices, foci, and sketch it. First step is to always take your equation and put it in standard form. It's definitely not in standard form. Once again, standard form, we've seen it many times before. Looks like one of these two. You've got a 1 on one side. You've got some fractions with numbers in the bottom. Looks like we got an x squared and a y squared term. Here's my number term. Let's maybe get that to the other side. So I'll add 36 to both sides. Now the first thing I know is this over here has to be 1, has to be the number 1. So what do I need to do to this equation to get this side to equal 1? Well, how about I divide everything on both sides by 36? Because now I have 1 over here. So here 9 over 36 is actually x squared over 4 plus y squared over 9. All right, that's looking a little better. So I've got the 1 here. I've got some fractions over here. I don't have any coefficients from x and y, but if I remember the equation, if I look, it's x minus h squared plus y minus k squared, and then the a or b. Here, I don't have any parentheses there. So what's the h and the k going to be? Well, once again, it's one of those cases where what happens is the h and the k is really 0. You do not need to write it like this. I'm just doing this to make it very obvious what's going on. In other words, the center is going to be 0, 0. But before we do that, as it turns out, this is step 1. This actually is in standard form. Step 2 was determine what kind of ellipse we have, up or down or left or right. And the key there is you look for the largest denominator. Here, 9 is bigger than 4, and 9 is sort of grouped up with the y. So second step says this is going to be somewhat of an up and down parabola. I look at my equation. The center, it's actually going to be at the origin. Let's just figure everything out and then we'll graph it. So now the a and b, the a now is always the larger denominator. So a squared is 9, which means a is 3. B squared is 4, which means b is 2. So now I have everything I need to sketch this parabola listed over here. So there's the center of my origin, and since it's an up or down parabola, my major axis looks like a is 3, so I go up 3, then down 3. And my minor axis, the distance is going to be 2, so I go 2 to the right, 2 to the left. And then I can sort of try and not perfect, but there's basically what the ellipse looks like. So therefore, the center is 0, 0, the major vertices would be, looks like 2, 0, and -2, 0. And their minor vertices, whoops, I messed up, right? Because the major's up and down. Wow. So it's actually 0, 3, 0, -3, and the minor vertices are 2, 0, -2, 0. Wow. And the last step are the foci, which we call c. C squared equals a squared minus b squared. A squared's 9, b squared is 4, looks like it's 5, so this time c is square root of 5. My calculator, see what that is as a decimal, 2.2. So if I try and draw it up here, maybe this will be a foci, and maybe, and as actual points, wow, I messed up again. You gotta be careful with these. Actually, it's gotta be up here along the major axis. I'm glad I caught myself. So it's going to be 0, 2.2, and 0, -2.2. All right, not that hard, but you can see here I made a couple mistakes as I was doing it. Just got to be careful.